rotate list. So given the head of a linked list, rotate the list by k places. Basically, from looking at these examples, what it wants us to do is rotate this list ultimately so that the first k elements from the end will make up the first part of the list. Like in this example, k is equal to 2. So ultimately, the 2 elements at the end of the list are going to be rotated around to the front, and so they will be the start of the list now. And in this example here, it's the same thing. So if k is bigger than the length of the list itself, that means there'll be a full cycle. So we can kind of just disregard the cycle, but then what's remaining is what's remaining is the value that we want to be the start of the list. So here k would ultimately be 1 after the cycle. So the first k element from the end of the list will be the new start. Let me just look at the constraints real quick. Okay, so it seems that I have a good grasp of what needs to be done. We're rotating the list to the right by k places, which ultimately means that k elements from the end of the list will then be the start. So the first thing I would want to check for, I think, is if there's a cycle, or I'd want to get the value of k after any cycles, which means that I need to first get the length of the node, the length of the list. Once I have the length of the list, I can get the k value without any cycles. And then I think what I want to do is I want to make the end. Okay, so what I want to do is I want to make the end node point to the first node. As long as k does not equal 0, I want to make the end node point to the first node. And then I want to make the element that is pointing to the kth element from the right, so the second element from the right, in this case 4, the element pointing to that element 3, I want to make null. And then I will return this element as the new head. And I think that is going to work. Like in this case, k will be 1 after I remove the cycles. So first thing I will do is I make 2 point to 0, and then 1 will be null. And then there we go, 2, 0, 1. And then 2 would be the head. So I think that is what I want to do. And so what I can do Okay, so let me go ahead and code this out now. So the first thing I want to do is get the length of the linked list. So list node start equals 0, while, I'm sorry, not 0, equals head, while while start does not equal null, int length equals 0, while start does not equal null, length plus plus, start equals start dot next. There we go. So after this, I should have length will contain the length of the list node. The length of the list. Sorry, the linked list. Okay, so now that I have length, I want to get rid of any cycles, because they're kind of irrelevant, because a cycle just means that it's going to be back in the same place that it originally was. What I mean by a cycle is basically 3, basically a cycle meaning a value of k which is greater than the length of the node of the whole list means that the whole list will circle back to what it originally was. So the way I can do that is a simple while loop. So while k is greater than length, k minus equals length. Okay, now what I want to do is if k equals 0, if k is equal to 0, then we don't need to rotate it at all. So then we can just return head. Okay, so now, next up, so okay, first thing I think I want to do is I want to make the last node equal to, point to the first node. And I'm just thinking once I have that, then next thing I can do is I can, okay, that makes sense, but I still need to keep a pointer to pointer to the node that is going to be my new head, which is k from the left, from the right. So to do that, I can just, and I want to do that before I make the node before it null, because then I won't be able to reach it because it'll be the head. So I need a pointer to pointing to that head before I do anything. So let's do int target equals length minus k, and that means that it will basically represent the how far out this node is from the left. So in this case, length is 5, and then k is 2. So 3 is our target, and 0, 1, 2, 3 would put us here. So that's how I'm going to get to this head value. So let me list node new head, new head. Okay, so for int I equals 0, this node new head equals head. Okay, so for int I equals 0, I smaller than target. Okay, this should put us to here. So now that we have this, we can just keep track of new head. Then next up, I want to get to the last element in the node. So while head dot next is not null, head equals head dot we'll do so this should take us to the last element, and then we'll simply do x dot next equals head. Now the last thing I need to do is I need to get to the element that's pointing to new head, and I need to make that element point to null. So to do that, I can to do that I can just iterate through head. Um, so, but I'm just trying to think if this will work for every case. But let me go ahead and try it. Okay, so while head.next does not equal let's give it a run. Okay, there we go. Accepted these cases. Let's see if it works for everything. Okay. If head equals null, return head. Okay, there we go. Not too good with the time complexity, but at least we got it done.